Number 15. As part of a fitness challenge, Julie will do 5 push-ups on day 1. Then each day after that, she will do 2 more push-ups than she did the previous day. On what day will Julie first do at least 100 push-ups? Okay, this one just smells like a function problem. These kinds of problems can be solved several ways. I'll show you the way I would do it. It's really a pattern problem, and that's why it's a function problem, because if you can identify a pattern, you can identify a function. And to set this one up, I'm going to draw a pretty complicated table. I'm going to make a space for it and try to at least get it down here in frame. And I'm going to put, I believe, 4 columns. I may have to add another one, but let's do, there's one. This is going to be for the input. Which in our situation is represented by the days. And then I need a column for, I'm just going to call this the math column. You'll see what I mean in just a second. And let's put a big space there. We're going to use that in a minute. And this is going to be the output. And this will be the actual number of push-ups. So let's take what we know and start building this table. On day 1, there's no math to do. She did 5 push-ups. It's pretty simple. 5 push-ups on day 1. On day 2, she did the number of push-ups she did the day before, so she did 5, but she added 2 to that. Each day she's going to do 2 more than the previous day. So 5 plus 2 is 7. I'm not going to go all the way to 100, I promise. I think I'll go to about 6 and stop. So here we have day 3. So yesterday she did 7 push-ups, and today she'll add 2 to that to get 9 push-ups. On day 4, she did the 9 from yesterday plus 2 more is 11. On day 5, she did the 11 from yesterday plus 2 more would be 13. And on day 6, she did the 13 from yesterday plus 2 more, which would be 15. And we need to let that go all the way until this gets to at least 100. Okay. And on day 1, there was no math to do. We just wrote the 5 out there. So stop the video if you need to and make sure that you really understand where these numbers are coming from, because that's the key to this next part. Normally, they'll give you an input-output table and ask you to write the function. But this time, they made us build our own input-output table. And the way I knew to do an input-output table is because we have a pattern going on. Every day, she's doing the same thing over and over. So, we need to come up with the function, or the other way to say that is the math rule that applies here. So, what is happening to get me from 1 to 5, or 2 to 7, or 3 to 9, or 4 to 11, it's that rule that occurs between the input and the output. And the key to this is that it must be the same rule all the way down. So if it works in the top cell, it has to work all the way down. If it doesn't work, it's not a function and it will not help us. We have to have a hard and fast rule that will work. So we have to come up with that. We have to figure out the rule. Where I would start is to think, okay, in each scenario from input to output, I am building up. At no time am I breaking down. And building up can only be done with addition and multiplying. Those are my two options for building up. So I could say 1 times 5 is 5, but 2 times 5, for example, if I try it right here, it's not going to work. 2 times 5 is not 7. So that is not the pattern. That's not the rule. I could say 1 plus 4 to get to 5, but 2 plus 4 is not 7. So neither of those will work. It's going to be a combination of the two things. So what if I said 1 times 2? That's 2. And then if I added 3, I would get 5. That's the simplest, using the lowest numbers to build up, that I could use. So let's try it here. Let's say 2 times 2, which is 4, plus 3. Okay, that is 7. Let's try 3 times 2, which is 6, plus 3 is 9. I'm liking this. 4 times 2 is 8, plus 3 is 11. 5 times 2 is 10, plus 3. This is the rule that I'm looking for. 6 times 2 is 12, plus 3 is 15. So we have found the rule. You multiply the input by 2, and then add 3. And I think the question you asked me was, why am I adding 3 and not 2? Because the question says that we're adding 2 every day. The reason is that you're taking the 2 that you're adding on every day and the day before. So in every situation, it comes out to be that you're adding 3 to, you could even get into even and odd numbers. The multiplying of the input brings you to an even number every time. And then you're adding on 3 to that to account for the 2 new push-ups and the day before. I know that's not a good explanation. I'm just struggling to put it into words. But if you can get your function, which is this part right here, you've got it. Now, you might be asking, how did I know to multiply by 2? I started with that because multiplying by 1 wouldn't help me. That's not going to change anything. And 2 is the next lowest number that I could have chosen. Most of these on a test are going to involve low numbers. So you'll multiply by a 2 or 3 and then add or subtract something. So I would always start with a 2 as the multiplier, and usually it will be something small. So I need to put this function into terms that I can work with. Now, remember, it says that we want to get to at least 100. That suggests that we could go over 100, but we want it to be at least 100. Okay, so our formula is going to be, oh, there's one other thing I need to show you. Remember another way to do input output. Input is X and output is Y. So we are going to do 2 times X, add 3, and that will give us the Y that we want. So Y is 2X plus 3. Just turning it around into slope-intercept form. And remember, we want Y to be at least 100. So the 2x plus 3 part of the problem has to come up to at least 100. So that gives me the function in equation form that I'm looking for. Now I need to solve it. Once you get that equation written out, or inequality in this case, let's solve it. So I'm going to subtract 3 from both sides. And I'm left with 97 divided by 2x. I'm sorry, 97 is less than or equal to 2x. I'm going to divide by 2. So I have x is greater than or equal to, and remember x is the number of days. So 2 into 9 is 4. 2 into 17 is 8. So x would have to be greater than or equal to day 48. Actually, no. It's not equal. It's 48 and a half. So that would bring us to at least day 49. I almost messed up right there. And that's so typical of me, because I will try to take a shortcut and not finish my division. And you see what trouble I get into. So it would have to be, we can't drop down to 48. It has to be bigger than 48 and a half. And the first choice I would have there would be 49. So I would go with option D. That is a good, hard problem.